Welcome to our presentation on comparison between serverless and containers cloud computing architectures. Today, we'll delve into the fundamental differences between these two architectural paradigms, exploring their characteristics, advantages, challenges, and the scenarios where each excels. By the end of this presentation, you'll have a clearer understanding of which approach best suits your project's needs and considerations. So, let's dive in and explore the world of serverless vs containers cloud computing architectures. In this presentation, we'll cover various aspects of serverless vs containers cloud computing architectures to provide you with a comprehensive understanding of their differences and applications. Here's what you can expect. First, we will look at serverless computing architectures and how it revolutionizes cloud application development by eliminating the need for managing infrastructure. With automatic provisioning and scaling, developers focus solely on code. Next, we will look at containers cloud computing architectures and how it offers a standardized approach to deploying applications, ensuring consistency across various environments. Docker and orchestration tools like Kubernetes streamline deployment and management. Next, we will dive deeper into the comparison and explore the distinctions between serverless and containers, including management overhead, scalability, and pricing models. We will also look at some real-world use cases and discover scenarios best suited for each architecture, from event-driven applications for serverless to microservices for containers. Finally, we will look at the factors to consider when choosing your solution, which will help you evaluate workload characteristics, development expertise, vendor lock-in, cost analysis, and performance requirements to make an informed decision. Serverless computing represents a paradigm shift in cloud application development, liberating developers from the complexities of infrastructure management. This architecture leverages the cloud provider's capabilities to automatically handle server allocation and provisioning, allowing developers to focus solely on writing code. By abstracting away the underlying infrastructure, serverless architectures enable rapid development and deployment of applications without the burden of server maintenance. In serverless computing, applications are built using an event-driven architecture, where functions are triggered by various events such as HTTP requests, database changes, or file uploads. This event-driven approach allows for a highly responsive and scalable system, as functions are invoked only when needed. Moreover, serverless architectures operate on a pay-per-use pricing model, meaning developers are charged based on the resources consumed during the execution of their code. This results in cost savings, as resources are allocated dynamically and scaled according to demand. Additionally, serverless functions are stateless, ensuring that each invocation is independent and isolated from previous executions, leading to greater reliability and scalability. Now let's look at some advantages of serverless computing architecture. First is auto-scaling. Serverless architectures inherently support automatic scaling, allowing applications to seamlessly adjust resources based on workload fluctuations. This dynamic scaling ensures optimal performance and resource utilization, enabling efficient handling of varying workloads without manual intervention. Next is cost-effective. With a pay-per-use pricing model, serverless computing offers cost-effectiveness by charging users only for the resources consumed during function execution. This eliminates the need for upfront provisioning and minimizes costs associated with idle resources, resulting in significant cost savings for organizations. Finally, simplified management. Serverless architectures relieve developers from the complexities of infrastructure management, as cloud providers handle server provisioning, scaling, and maintenance tasks. This simplification allows developers to focus solely on writing code and building innovative applications, thereby accelerating development cycles and reducing time to market. Containerization, a cornerstone of modern cloud computing, revolutionizes application deployment by encapsulating applications and their dependencies into portable units called containers. These containers offer a standardized environment for running applications, ensuring consistency across different computing environments. At the heart of containerization is Docker, a popular platform that simplifies the creation, deployment, and management of containers. Docker's intuitive interface and robust features empower developers to package applications into containers effortlessly. To orchestrate container deployment and management, tools like Kubernetes and Docker Swarm provide powerful solutions. These orchestration tools automate container scaling, networking, and load balancing, enabling seamless deployment and efficient resource utilization. One of the key benefits of container cloud computing is resource isolation. Each container operates within its own isolated environment, ensuring that applications run consistently and securely without interference from other containers. In summary, container cloud computing offers portability, scalability, and consistency, making it an ideal choice for deploying and managing modern applications in the cloud. Container cloud computing operates on the foundation of containerization, a methodology that packages applications and their dependencies into portable units known as containers. These containers provide a standardized environment for running applications, ensuring consistency across various computing environments. At the forefront of containerization is Docker, a widely adopted platform that simplifies the creation, deployment, and management of containers. With Docker, developers can package their applications into containers with ease, streamlining the development and deployment process. To manage the deployment and scaling of containers, orchestration tools like Kubernetes and Docker Swarm come into play. These tools automate the deployment, scaling, and networking of containers, providing a robust infrastructure for running containerized applications at scale. One of the key features of container cloud computing is resource isolation. Each container operates within its own isolated environment, ensuring that applications run independently and securely without interference from other containers. In summary, container cloud computing offers portability, scalability, and consistency, making it an ideal choice for deploying and managing modern applications in the cloud. Container cloud computing offers several advantages that make it an attractive option for deploying and managing modern applications in the cloud. Firstly, portability is a key benefit of containerization. Containers encapsulate applications and their dependencies, making them highly portable across different computing environments. This portability allows developers to build once and deploy anywhere, ensuring consistency and flexibility in application deployment. Secondly, scalability is inherent to container cloud computing. With orchestration tools like Kubernetes and Docker Swarm, containers can be automatically scaled up or down based on demand, ensuring optimal resource utilization and performance. Thirdly, consistency is another advantage of containerization. Each container operates within its own isolated environment, ensuring that applications run consistently regardless of the underlying infrastructure. This consistency simplifies deployment and management, reducing the risk of configuration errors and ensuring a reliable application environment. In summary, container cloud computing offers portability, scalability, and consistency, making it an ideal choice for deploying and managing modern applications in the cloud. Let's delve into the comparison between serverless computing architectures and container cloud computing to understand their distinct characteristics and use cases. Starting with management overhead, serverless computing boasts minimal management requirements as cloud providers handle server provisioning and maintenance automatically. In contrast, container cloud computing involves moderate management overhead, as developers are responsible for managing container deployment and orchestration. In terms of scalability, serverless computing shines with automatic scaling capabilities. Serverless architectures can dynamically adjust resources based on workload demand, ensuring optimal performance and resource utilization. On the other hand, container cloud computing supports manual or automatic scaling, providing flexibility but requiring more hands-on management. Regarding cold start times, serverless computing may experience noticeable delays when functions are invoked for the first time, known as cold start times. In contrast, containerized applications typically offer faster startup times due to their persistent nature. Resource utilization differs between serverless and container architectures. Serverless computing optimizes resource usage for individual function requests, while resource utilization in container cloud computing depends on the size and configuration of the containers. Pricing models also vary between serverless and container architectures. Serverless computing adopts a pay-per-use model, charging users based on actual resource consumption during function execution. In contrast, container cloud computing often involves paying for provisioned resources, regardless of actual usage. Flexibility in runtime environment control differs between serverless and container architectures. Serverless computing offers limited control over the runtime environment, as it's managed by the cloud provider. In contrast, container cloud computing provides greater control over the runtime environment, allowing developers to customize container configurations according to their needs. Development complexity varies between serverless and container architectures. Serverless computing simplifies development by abstracting away infrastructure management, while container cloud computing requires knowledge of containerization tools like Docker and Kubernetes. Use cases also differ between serverless and container architectures. Serverless computing is well suited for sporadic workloads and event-driven applications, such as IoT data processing and real-time analytics. Container cloud computing, on the other hand, excels in consistent workloads and microservices architectures, where applications are broken down into smaller, manageable services. Lastly, environment isolation distinguishes serverless and container architectures. Serverless computing provides fully isolated environments for each function, ensuring security and reliability. In contrast, containers share the same kernel and resources, providing a balance between isolation and resource efficiency. In summary, the choice between serverless computing and container cloud computing depends on factors such as workload characteristics, development expertise, and performance requirements. Serverless computing is ideal for applications with event-driven workflows and sporadic workloads. Let's delve into some specific use cases. First is event-driven applications. This includes scenarios like IoT, Internet of Things, data processing, and real-time analytics. With serverless, you can efficiently handle bursts of incoming events without worrying about provisioning or managing servers. For example, imagine a smart home system where sensor data triggers automated actions, such as adjusting room temperature based on occupancy. Next is sporadic workloads. Serverless is well suited for tasks that don't follow a consistent schedule, such as scheduled tasks and batch processing. For instance, you might have periodic data cleanup or report generation tasks that occur at irregular intervals. Serverless allows you to execute these tasks on demand without incurring unnecessary costs during idle periods. Containers are best suited for applications following a microservices architecture and those with consistent workloads. Here are some typical use cases for containerized applications. First is microservices architecture. Containers excel at breaking down complex applications into smaller, independently deployable services. Each microservice runs within its own container, enabling teams to develop, deploy, and scale components independently. For example, a large e-commerce platform might consist of separate microservices for inventory management, payment processing, and user authentication. Next is consistent workloads. Applications with predictable resource requirements benefit from containerization. These workloads typically require a stable environment with controlled resource allocation. Consider a web application serving a steady stream of user requests. By containerizing each component, you ensure consistent performance and resource utilization across deployments. When selecting between serverless and containerized architectures, several factors come into play. Let's explore these considerations in detail. Firstly, workload characteristics. Understanding the nature of your workload is crucial. Evaluate whether your application exhibits sporadic or consistent usage patterns. Serverless architectures shine in handling event-driven and unpredictable workloads, whereas containers are better suited for steady, predictable workloads. Next is development expertise. Consider the skill level of your development team. Serverless computing abstracts away infrastructure management, making it accessible to developers with minimal cloud expertise. On the other hand, containerization requires familiarity with container orchestration tools like Docker and Kubernetes. Assess your team's proficiency to determine the most suitable approach. Moving on, vendor lock-in. Evaluate the degree of vendor lock-in associated with each solution. Serverless platforms often tie you to a specific cloud provider's ecosystem, limiting portability. In contrast, containers offer more flexibility, allowing you to deploy across various cloud environments or on-premises infrastructure. Consider your long-term strategy and the implications of vendor dependence. Additionally, cost analysis. Analyze the cost implications of both architectures. Serverless pricing models are based on usage, offering cost savings for sporadic workloads. However, continuous execution of functions may result in unpredictable billing. Containers, on the other hand, require provisioning resources upfront, but offer more predictable cost structures. Calculate the total cost of ownership, TCO, for each option to make an informed decision. Finally, performance requirements. Assess your application's performance needs. Serverless platforms excel in handling short-lived, stateless functions with low latency requirements. Conversely, long-running or resource-intensive tasks may benefit from the isolation and control provided by containers. Consider factors such as latency, scalability, and resource utilization to ensure your architecture meets performance expectations. And with that, we've reached the end of our presentation. We hope you've gained some valuable insights. If you have any further questions or would like to explore more, please don't hesitate to leave a comment. Thank you for your time and attention. Please consider subscribing. Your support means the world to us at Consultant Bot. Every like, subscribe, and share helps this channel thrive.